The agenda for today's session is tracking the key metrics of your web server. And that web server could be an Apache, IIS, Nginx, and NGINX Plus. And other from the other side, we'll be discussing on optimizing the URLs, that is the websites which is hosted on top of these web servers, and how to optimize the URLs or to deliver the better user experience. And the next level of URL monitoring, that would be the synthetic transactions monitoring, which we call it as real browser monitor. And finally, we'll be moving on to the monitoring the unauthorized content changes in your website using our website defacement monitoring solution. Just a small housekeeping activity before we get started. We have our expert panelists available during this course of webinar. If you have any questions, you can just type it in the webinar chat panel and you can get an instant responses from our experts. With this, we can get started without much ado. Let's see how a website is modeled in a typical IT systems. As you can see in this picture on the right hand side, a web server could be an Apache Nginx, and there is a backend components like Java, .NET, Ruby on Rails, and SQL DBs. So all these components very integrated or tied with each other to keep your applications up and running. If any of these component goes down, that's where you get complaint from the users saying that the application not accessible, or there is a multiple error codes happening in your application whenever it is accessed, or a specific transaction is not available. So how to find these issues and be proactive in terms of monitoring and reduce the complaint from the users by implementing a strong monitoring solution. And that requires the web servers monitoring. As in, you could see that these Apache, Nginx, and IIS servers are responsible for delivering the web pages. So it is important to keep a track on these specific web servers. Let's take a typical scenario right here. Assume that a user wanted to access google.com and we use the web client, and this web client could be any browser. In the web browser, you just type google.com and this web browser initiates a get request to the web server, and this get request is traveling in the global area network, and the web server again responds back to the user with the content requested by the end user. And again, this takes back the global area network path, and the content requested by the user is sent in the form of packets. If there is any network level latency, the application slowness might happen. And that's what we'll be primarily discussing on the end user monitoring, and we'll be discussing on the specific web server monitoring as well in this specific webinar. Let's see the importance of the web server monitoring. And if your web server is running out of capacity, that's where your web server may not be able to handle the additional user request from the customers. So it is important to keep a track on these requests that your web server is receiving, and the traffic spike, increase in the traffic spike could lead to the high number of web server requests. So analyzing the historical data and planning the capacity accordingly plays a vital role in terms of monitoring your web servers. And the monitoring the web server will also help you to track the popularity and the growth of your website. What do I mean by the traffic? I mean the popularity and the growth of websites. So if your web server is receiving high number of requests, that means your website is being popularly accessed, and you can see the high number of traffic results in the popularity of the website as well, which can be a direct correlation. So understanding the backend IT infrastructure outage is very important factor in terms of monitoring. And the supported component failure, it could be an operating system, as we have seen in the previous slide. If there is an issue with the operating system, or it could be an issue with the DB, could also cause the application slowness or the website slowness irrespective to the web server monitoring. So it is important to keep a track on these supported components of your web apps. Let's see the supported web servers that you can monitor using the applications manager. So since the web servers handle the user request for content, their performance has an immediate and noticeable impact on the end user's experience. If the web users are slow, if the web server is slow, definitely the users may abandon the specific website and may go for a different competitor site. So that's what it is important to monitor these web servers. And in Applications Manager, you can monitor the popular and widely used web servers like IIS, Apache, Nginx, and commercial version of Nginx, that is NGINX Plus. And you could also monitor the HA proxy and memcache as well. So we can quickly get started with the Apache Web Server Monitoring. So in Applications Manager, the web server monitoring is performed in an agentless way. So the Apache web server, as we all know that it's an open source web server, and this web server is actually not a server which is sitting on top of a physical server, or it could be an virtual machine. So it's a software which is installed on a specific host machine, and when it is installed, the web server triggers multiple child process which actually takes the request from the user and process the request, and by this way the request is being processed back to the end user whoever is requesting the specific data. When the user is requesting a data, the web server loads the specific page from the indexing and delivers it back. So as a first step towards monitoring is discovering your Apache server. So in Applications Manager, by providing the IP address of the host machine, port number, and you could provide the server status URL. After providing these details, we discover your Apache server and start monitor the key performance indicators KPIs of your Apache server. The primary KPIs which someone will get benefited is response time, request details. So the response time will help you to gauge your server's health, including the rate of request, request latency. Yeah. So if the response time is high, that's where the website slowness may happen. So Apache is again often compared with other popular web servers like Nginx and IIS as well. So each of which have its own variety of functionalities, pros and cons. And we are not going to discuss about that. We'll be primarily discussing on the monitoring aspects of these web servers. And other important metric is the busy server, bytes transferred, the availability of your web server. Let's see the Apache request details. This specific metric is used to measure the server performance. If the Apache is processing your request slowly, it could be due to other components of your stack, such as long-running queries or slow execution of code. Monitoring all your systems in a way, you can correlate the performance data across multiple components to identify such issues. If your metrics indicate that the latency is due to Apache itself, you may want to experiment with reducing the keep alive timeout of the specific server. If the rate of request is dramatically increasing for your Apache server, again, you may want to allocate the resources to handle the sufficient number of load. And let's see the other metric in terms of Apache server monitoring, that is the busy servers. At the most basic level, Apache processes the client request and delivers back. So resource utilization and activity metrics can help you determine whether your servers are effectively utilizing the system resources and whether they have enough resources or capacity to complete the or to process the additional request which the server is receiving. On the other hand, probably you could also notice high number of busy servers, and if there is high number of busy servers, that's where you may have to increase the service load. accordingly, and the bytes transferred information, that is the bytes per second value, and you could configure alarms for all these values, and I will be explaining that in the web console. So I'll be moving to the Applications Manager web console to show you a more hands-on experience of the solution. So we are in the Applications Manager web console now. As a first step, let's start with the Apache Web Server Monitoring. I have already added an Apache server in my environment and show you the performance metrics which we monitor. The response time, that is for the past 1 hour, you could see the value in millisecond. CPU load information, request details, that is the request per minute and the bytes per request values being shown. And you could also drill down to the historical values by choosing this icon right here and get the historical data for it. Busy servers information again gives you the other informations like the idle servers information also. So it's important to keep a track on these busy servers, and the bytes transferred gives you a direct measure of how the web server is processing your request. If there is more number of bytes, then that's a direct measure that your web server is delivering huge number of requests. If there is more number of requests, more number of bytes transferred will be high. Let me switch back to the presentation and discuss about the next topic for today, that is IIS, Microsoft IIS Server Monitoring. So IIS is the proprietary server of Microsoft, and which is again one of the most widely used web server in the market. So similar to the Apache web server, IIS server has multiple worker process, and which is named as w3wp.exe. So using Applications Manager, you can monitor the worker process along with the application pools. So let's get started with the IIS server monitoring. The first step towards monitoring is discovering your IIS server. You can provide your IP address, port number to get started with the monitoring. So after providing the details of your IIS server, let me show you the key performance indicators that we monitor. Similar to the Apache server, here also we monitor the response time and application pools information, website statistics, worker process, and the availability information of your IIS server. One of the primary advantage of using IIS as a web server is all of the metrics is available from the WMI classes. So from where we fetch all this data. When a website which is hosted on an IIS slows down, the underlying issue could be an IIS itself. And we cannot confirm that the issue is again with the IIS, and multiple sub components needs to be analyzed before reporting a specific issue. An applications manager helps you to find the system level resources, that is server resources. Similarly, high memory utilization and inadequate resources handling could also lead to these issues. So you can see what other servers, that is IIS, is communicating with the other technologies, and can start monitoring the key resources across your servers and website to help improve the response time and maintain high availability and performance for your web servers. And let's discuss the primary metrics one by one for IIS server. So to ensure that your users can access your content, you need to monitor the availability of the several components of your IIS. You wanted to know when your application pools have recently started, restarted, or whether it is stopped. So you may want to know these information. You also wanted to get alert if IIS is no longer listening for an HTTP socket connection. In this specific section, we'll be discussing on the IIS metrics that give you insight into the availability of your server. Because we know that the website is the primary phase of your business communication with your customers, because nowadays that website acts as a primary first step communication whenever someone wants to engage with any of product or solutions. So let me choose to the next slide and show you the website statistics. So application manager can effectively monitor the bytes and files transfer per second in your website, and tracking these metrics gives you a clear picture of how fast your website is responding. Comparison of these statistics over a period of time will help to find a trend to facilitate higher bandwidth if it is required. You could also estimate the number of users on your website. So application manager monitors the anonymous and non-anonymous users per second in your website. A higher number of non-anonymous users can at times be a cause of someone might be abusing your site. So it is important to keep a track on the count of these users. And one of the most important metric is in terms of IIS server monitoring, application pool and worker process. As we all know that the worker process conducts the main work of the web server, that is handling the client request and serving back them. If IIS can handle requests with multiple worker processes at a time, depending upon your configuration, then a separate executable, that is W3 process, W3 WP worker process is initiated, which is belonging to a specific application pool, which keeps your application mutually isolated from multiple deployments to improve the availability of your applications. If a specific pool is affected, the other application will not go down. So by this way, you can make sure that your applications are running and you can see which application pool is being affected. So worker process in one pool do not share resources with other pool. So this working behavior helps a lot in terms of multiple deployments made in a single IIS server itself. So let me switch back to the application manager web console and show you the performance metrics in a real-time perspective. If you have any questions, feel free to type it in the webinar chat panel. Our expert panelists will be happy to answer all your questions instantly. So we are in the applications manager web console now. So let me choose the IIS server right here. So let me show you the first step of adding the IIS server, that is initiating the IIS web server, discovering the IIS web server. So for discovering your IIS server, as a first step, you need to add your Windows host server, and then you could specify the same IP address and the port of your IIS server, and then you can start monitoring of your IIS server. And the key metrics which we monitor in terms of IIS web server monitoring is, let me show that metric for you. The website statistics, the multiple deployments that you have performed on top of these web servers. So irrespective to the number of deployments you have made, application manager can discover all these website deployments and can show you the availability and health of your specific web apps. And we show you the last 1 hour connection statistics, bytes transferred information as we have seen in the presentation, and files transferred, users count including the anonymous and non-anonymous users count. So let me switch back to the presentation and discuss about the Nginx monitoring. So similar to IIS server, Nginx is one of the most popular HTTP server. It is not only a HTTP server, but also it is a reverse proxy server. It acts as a load balancer. So the Nginx server serves the content very efficiently and reliably because it uses a non-threaded mechanism, unlike the Apache. It also works on an event-driven mechanism. It has a single master process. Multiple worker processes were associated to a single master process. The worker process again handles the request from the user, and the worker process is tied up with multiple internal loops. So how the worker process accepts the new request from the shared listen socket, and these master process is again responsible for reading and validating the configuration and then assign the work to a specific worker process. And again, the worker process is associated to a proxy cache, and again it has another component, that is cache loader, which helps you to take the data directly from the disk cache and respond back to the request instead of passing through the regular workflow of master, worker, and then HTTP request to the web server. So by this, if a web page is retrieved from the proxy, the page load time is very less for a user. And also the cache manager helps the Nginx server for the cache expiration and validation process. The first step towards monitoring is discovering an Nginx server. You can specify the host name, port number, server status information, and can start monitoring of your Nginx server. So basically, by monitoring Nginx, you can catch two categories of issue: resource issue within Nginx, and also other issue developing elsewhere in your web infrastructure. Let's see the key performance indicators of Nginx. The metrics that the most Nginx users will be benefited from monitoring is requests per second, response time. So the response time gives a direct measure of how well your web server is responding, and the request in various status. Again an important metric that I would recommend for the users to monitor in terms of high load production systems, specifically the request in various state. So let's discuss these metrics one by one. So before we discuss about these metrics, let's see how a connection is being actually processed. Okay, an active connection. Okay, when a user requests and initiates a connection, that is triggered as an active connection to the web server, which could be in a waiting substate if there is no active request at a specific moment. A new connection can in fact bypass this state and move directly to reading. So most commonly, if you have configured accept filter or a deferred accept in your configuration of your Nginx. So let me switch back to the application manager web console and discuss about the Nginx monitoring. And let me choose managers right here. And in the web server services category, I'm going to choose Nginx. So after choosing Nginx, you can see the performance metrics that we monitor. That is the response time, active connections information, request per second, request in reading state, and the request, most importantly, the request in waiting state. So the connections will also be in the waiting state, right? After sending a response, if the connection is set to keep alive. So you could monitor these kind of requests right here using the request in waiting state attribute. And also you could configure alarms using these options of configure alarms and get a proactive notification before something is seriously happening inside the web server. And let me switch back to the presentation and discuss about the next topic for today, that is NGINX Plus. So similar to Nginx, NGINX Plus is a commercial licensed software, licensed web server. Now the NGINX Plus is part of F5 networks. So NGINX Plus acts as an enterprise grade load balancing. The enterprise grade features might include the session persistence, active health check, dynamic reconfiguration of the load balance server groups without a server restart. So, uh, as we all know that the NGINX Plus is going to be an enterprise version, the primary prerequisite for monitoring your NGINX Plus in Application Manager is enabling the API model. So this API model should be enabled so that we fetch the data from the API and we show it to you in the Application Manager with all the key metrics centrally. So you could refer this documentation to enable the specific API to start monitoring of your enterprise grade Nginx Plus systems. Let's see the basic functionality of the Nginx server so that we can see the key performance indicators that we monitor. So the Nginx server has three different components: the server itself, server zones, upstream zones. In each of the traffic handling context, you can include one or more server blocks to define the virtual servers. And these virtual servers were nothing but it's not actually a physical machine or a server itself. It's just a configuration file which is created in the Nginx Plus machine server. Okay, and this configuration, the virtual server, reroutes the request to the upstream zones, which acts as a cluster. Then the cluster will again route the request to the upstream servers, which handles the request. And this happening, and all these things happening in a very fast way. And Nginx Plus has a wide variety of load balancing methods. And by default, it uses a round robin method. So now let's see the how application manager can help you in terms of Nginx Plus monitoring. So the primary metrics that we can monitor in applications manager is connection statistics, which includes SSL connection, HTTP connection, and the upstream zones value, which includes the outgoing traffic and the incoming traffic. At a very high level, configuring Nginx Plus as a web server is a matter of defining which URL it handles and how it processes the HTTP request for resources at those URLs. At a most basic level in terms of layman's, the configuration defines a set of virtual server. That is the previous slide we have discussed about the virtual servers that control the processing of requests for the various particular domains, or it could be an IP address also. Okay, so let me switch back and show you the other metrics, that is the HTTP and TCP upstream server, response time, throughput, and health information. The cache information gives, we in fact show you the metrics like hit ratio, cache size, responses rate also. So Nginx Plus provides out of band application health check as it is going to be an enterprise grade. So we do monitor the health check in applications manager also by fetching the data from the APIs. So Nginx Plus caching also helps you to get the data web pages very quickly, and we can show you the cache size and hit ratio for the same. So let me switch back to the application manager web console and show you the performance metrics that you can monitor using the Nginx Plus. Let me choose monitors, choosing Nginx Plus right here. So the primary metric that you could notice is the connection details, SSL connections, failed SSL connections, and if there is more number of failed SSL connections, that's something that you have to notice, that um, that is the user cannot connect to the web server in a secured way. So this gives you a direct mechanism of that. It's a direct reflection of it. And the reuse sessions, it should be high. The SSL sessions reused value should be high for proper optimization of your web pages. And the HTTP request, which is a direct response received by the web server if it is configured as a web server. And you could also see the request rate, current HTTP request value. And most importantly, the other information is the server zones. And we discovered all the server zones, that is these configuration files, the whatever it's configured, and the request received, discarded, response code for it. And you could see the graphical information for the same right here, the bytes received rate and bytes sent rate, and the response code information, in which includes the request received and request discarded. And in the upstream option, we show you the zones, HTTP request received. When you click a specific zone, you could see the data associated with the upstream server, because the zone reroutes the request to the upstream server, and the upstream server again send the responses to the to the actual servers where it actually handles the request. So you could see the upstream server for which the zone is associated, and see the health checks failed percent also. HTTP request received for a specific upstream server. You can also configure alarms for all these columns by just choosing this. You can choose the column value and get a proactive notification for the same. And as I mentioned earlier, caching again helps you to deliver the web page as it uses the disk cache information and uses them to respond back to the clients without having a proxy request in between for to save the same content every time, so that when the page is retried from cache, it is much faster than the regular way. So monitoring this cache is again an important term for that behavior. And you could see the max size hit ratio, which is the most important metric of the cache, and the valid responses read, expired responses for it, and the responses missing in a specific cache. And you could see those data for it right here in the graphical information, and the responses read breakup and the not read breakup for the specific cache, and the TCP UDP zones. This is specifically in terms in case if you have configured the load balancer as a, if you have configured NGINX Plus as a load balancer, you could see these metrics, and you could see the zones, discovered zones, connections received, and the zone response code. And again, TCP UDP upstreams values and the current number of connections received information. So now we have discussed about the backend components which is responsible for delivering your web pages. In a more real-time perspective, the user accesses your web page by just hitting the URL from a web browser. So let's see how you can monitor your website in terms of end user perspective, and let's start from basic to the advanced ways of monitoring your websites using the Applications Manager solution. So let me switch back to the presentation and see the various ways that you can monitor your websites using Applications Manager. The most basic way is URL monitoring. Say for example, you enter google.com in your browser, and if you see that the web page is opening, that means the server is responding. So that's what we will be doing in the URL monitoring, and I'll show you the additional metrics that we monitor, and the URL sequence and the website content monitoring. So there's a hacker, if a specific hacker can break your web server and modify the specific content hosted on the website. It could be an indexing page, it could be of any pages. So by implementing the website content monitoring, you can prevent those kind of issues. And finally, we'll be discussing on the synthetic transactions monitoring for the effective website monitoring in a more real-time perspective from the end user, from different geographical locations, and by performing a mimic of the user interactions also. The URL monitoring, we show you the response time, the NS time, connection time for the specific URL, the first byte name and last byte time information. And the URL sequence monitor works similar to the basic URL monitor, but excepts it allows you to monitor several web pages in a sequence of the user-based activities. For example, if a user starts on a shopping cart of Amazon.com and goes through the checkout and payment pages, every web page is being monitored in the sequence of the user-based activity. So that's what we'll be performing in the URL sequence monitoring, which includes the same performance metrics, that is the DNS time, connection time, first byte time information. So for performing the URL sequence monitor, Application Manager provides Web Transaction Recorder. And this Web Transaction Recorder acts as a single tool to monitor your URL sequence along with the synthetic transactions monitoring, that is the real browser monitor. So once after discovering the URL sequences, this is how it looks like, wherein we discover all the parent and child URLs based upon the user activity, and we start monitoring it. So with this, let me switch back to the Applications Manager Web Console and have a quick understanding of what we have discussed in a more real-time perspective. As a first step towards the URL monitoring, you can choose Add New Monitor and specify the URL which you would like to add, and you can get started right here. And also we provide the HTTP configurations through which you could customize the ways that you are adding the URL. In fact, you could also monitor the dynamic URLs using the Manage Engine Applications Manager. If you have any questions on configuring the dynamic URL monitoring, you could add a comment in the chat panel so that our expert panelists will answer in configuring the dynamic URLs. And also you could perform the content check, and client-side authentication again can be performed. For that, you have to just upload your SSL certificate right here and the password. So With this, I will show you the other performance metrics that is important in terms of URL sequences monitoring. And to perform the URL sequence monitoring, one need a web transaction recorder. And this web transaction recorder can be downloaded from our website. And if someone needs a link, we can share it in the webinar chat panel. So once the web transaction recorder is downloaded and installed, all you have to do is just specify the host name right here of your applications manager install machine, and then specify the SSL port number right here and username and password which you use for applications manager login. So after providing these details, you can quickly get started with the monitoring aspects. And you could choose the create URL sequence monitor, which is available on the left and bottom side, and enter the URL for which you would like to capture the sequences. So let me choose the specific URL and we can get started for it. So I'm choosing the URL and I'm just performing a playback of the sequences. That is, I'm choosing get code and I'm choosing demo right here. And now I'm choosing preview and save. And now you could see this pop-up appearing, and here you can provide a name for the sequence and the polling interval for the same. And you can choose next, and you could see that all these URLs has been captured based upon the activity that I have performed. And you could use this filter option to remove the unwanted URLs. That is, that could be a third-party dependencies and image links. So those can be automatically filtered by using these options. Let me go back to the Applications Manager web console, and I'll show you the data populated in a more real-time perspective. And choose monitors, and right here I'm choosing URL sequence, and let me show you the sequence which I have captured earlier. So now you can see that it has already captured the sub pages based upon the activity that I have performed, and you could see the aggregated response time for all these URLs right here in the parent monitor page, and the average response time for all these web pages, including the current response time. And if you want the individual URL or the web pages response time, you could go inside and see the high level data of the response time and the response time split up and the page size information. And similarly, you can configure alarms by using these options for these attributes and get a proactive notification from the tool. Hope this is clear. So let me go back to the presentation and start with synthetic transactions monitoring using the Manage Engine Applications Manager. So providing the seamless end user experience for your website visitors is crucial in terms of business, developing a great business. So capturing the errors, network request, page load details of your critical website is an important term. So how you can monitor it in a global based perspective. Say you have a business and you have users globally. So you can deploy the end user monitoring agents in a different geographical locations, and this end user monitoring agent will perform the playback of the actual user and perform the mimic right there and push the data back to the applications manager so that you can see your applications performance in a global perspective. It could be your branch office or it could be your client location from where your application is actually being accessed. Depending upon that, you could deploy the agents in different location and can get the metrics. So an end user journey starts when a user sends a request from their client. That's what we have initiated. We have discussed in the first slide, and how the web server responds back to the request. And in between, we notice there is a global area network. So if there is any network level latency, if there is a packet loss, that could lead to website slowness. So how to identify those kind of network level latencies? So that we will be discussing in the end user monitoring. So you can install multiple agents in your different locations and can track the performance metrics from different locations worldwide. All you need is a secure HTTP connection between the agent and the applications manager server. So once you have this connection available, you could get started seamlessly. So to perform the end user monitoring, we have a specific term called real browser monitor, which performs the mimic of the user interaction, monitor your website globally, the different world from the different part of the world, reduce the blame game between the network team and app team. So if your website is slow, the primary reason someone would question is will go to the network team, right? So you could also see, you could show the data that there is an issue with the network team, or if there is an issue with the application team, you could use our APM insight to see if there is any issue with the application level components. So you could segregate and see whether the issue is happening in the app layer or in the network layer seamlessly. So the first step towards monitoring is recording a web script using our web transaction recorder. We'll be using the same recorder which we have used for the URL sequence monitoring. And here you have to launch the recorder, specify the host and port, perform the playback, and the playback is again sent to the EUM agents in the form of script, and the agent play back the data and send the data back to the application manager machine. So this is how it works in a very nutshell. And also you can monitor the critical workflows for your website. Someone, if you are an e-commerce business stakeholder, someone needs to shop your website, search for products, perform the payment checkout. So these kind of critical activities that you can record using the web transaction recorder and perform the playback to see whether all these transactions were continuously available. The basic website monitoring will just check whether your website is up and running based on the URL based response. But in terms of automating the user related workflows, this advanced synthetic transactions monitoring will help you to understand more in terms of user based perspective. And also, you could see the deeper visibility of the multi-step user interaction. That is, someone is logging in, they are clicking a specific page, and then they are moving to fetching the reports, and they are again logging out. So how much time it takes takes them to fetch the reports. And you could also see and compare reports fetching time from different location. It's not always a reports fetching time. It could be multiple use cases. It's just an example that I am providing. You could also compare your web app performance across the globe, as in we show you the response time and the transaction time from different locations. Fetch the historical reports also. You can also optimize the front-end web components using our real browser monitoring. This, you can see the resource size and the resource count split up of all the elements comprising your web pages, such as HTML, CSS, script, image, etc. So if there is more number of image content in your website, that's where the users who is accessing your web page from a low latency or from a low bandwidth area may experience an issue. So it's important to understand the working behavior of your websites. So application manager can help you to understand that. You could also find the network level latency using your waterfall model diagram. So right here, each row represents an object that could be a text, image, JavaScript, or any third-party components. And each component makes the round trip time between the user to the server back to the user. So if there is any component which is being negatively impacted, it adversely impacts the performance of your users. So it is important to keep a track on these values again. Let's see the need for synthetic transactions monitoring. So previously we had discussed about the URL monitoring and the URL sequence. So wherein we just monitor the website by hitting the URL, and we show you the response codes of the value and show the DNS time, connection time information. In a more complex environment, implementing a synthetic transactions monitoring is more beneficial because we perform a playback of the mouse level and the keyboard level interaction, which is actually being performed by your users. And you can also make sure that the defined SLAs were met for your web applications. And you can also make sure that because of performance issues of your website, your revenue is not being impacted. So that is the most important criteria for the synthetic transactions monitoring implementation. So I'll be showing you a live demonstration of how to capture the real browser monitoring using a web transaction recorder. So let me launch the web transaction recorder once again and show you the live actions that can be performed. So similarly, let me choose the host name, that is the my host name right here, and the SSL number, SSL port number. If you're not sure about your SSL port number, you can always verify your AIM server.properties file to check the port number. The username and password which you provide for applications manager login. And on the bottom right hand side, you can choose create real browser manager and perform the actions for the specific website. So I'm loading the Amazon.com as an example right here. And the first step is loading the site, and this next step I'm just assuming that I'm just performing a login right here. And after providing your credential, authentication happens, and you can get started with that. So I have successfully logged in, and next step that someone would be performing is searching for a specific product and then performing a checkout. So let me just give you a live, very basic example instead of that. So I'm choosing registry and I'm choosing buy again. So with this, I'll choose review and save. Pop-up appears, and you can specify a name for the playback that you have performed, that is a mimic of the user interaction. And here you could choose the agent from where you would like to perform the playback. So right here, I would like to perform the playback from the London location, so that I'm choosing the specific agent. If you have pointed multiple agents for the applications manager, all the agents will be shown up right here. And you could choose the polling frequency. And after that, you could choose next. And based upon the action that I have performed, you could see that I have loaded the Amazon.com, and including the mouse level and keyboard level interactions is being captured by the web transaction recorder. So by using this web transaction recorder, uh, someone it's not required to perform a Python script manually, because we have our integrated Selenium IDE with this specific web transaction recorder. So after performing the playback, you could just choose create real browser monitor, which will create the monitor in the applications manager, and the playback will happen in the end user monitoring agent. So let me show you how we populate the data. So I choose end user monitoring right here and choose the recorded sequence that I did earlier, and I'm choosing that. And you could see the average page load time for the specific transaction time, page load time for the individual steps that I have performed, which includes the page load time for the each and individual steps right here, and the resource size of the web page, and which includes the image content, script content, and the other front-end components. And again, you could see the network level latency, if there is any, will be displayed right here. And this is what the waterfall model approach for all these steps, the same details will be applicable, so that you can actually drill down and see if there is any issues in a specific time by analyzing our historical data as well. Hope this is clear. If you have any questions, please feel free to type in the webinar chat panel. Let's go to the final topic for today. That is the website content monitoring. So the website content monitoring in Applications Manager helps you to prevent unauthorized modifications performed in your website. So if a hacker can get an access to your web server, they can break the components of your web server and modify the potential components or the web pages, the elements of your web server to deface your web page. So it is important to have a proactive monitoring in terms of content monitoring of your website. So Applications Manager website content monitoring will help you to understand this. So defacement is again one of the subtle forms of the hacking. So as I had shown earlier, Let's take this example. Your banking page is being defaced by inserting a malicious code. So when it is inserted, the web page is defaced with the actual content, which degrades the actual business of the specific owner, and which is again adversely impacts the search engine rankings due to the web page defacement. It is typically done by hackers by performing code injection or cross-site scripting. So the first step towards monitoring the content of your website is initiating the monitoring from the applications manager. You can specify the domain URL. We discover the sub web pages when you choose the get web pages option, and you could choose the sub pages also. When you add your website for content monitoring, we check the integrity of your website by detecting the modification of the content and other critical elements. So we show you, this is the list of websites being monitored, and we show you the child web pages, deface script percent, text percent, and the page size value as well. So the fast detection of the security breaches on your website, including the unauthorized addition or modification of the HTML elements. In Application Manager, we perform a comprehensive monitoring of the HTML elements, which is defaced by the hackers. So there are standard hit checks, and we identify the changes in the HTML elements based on the href and the src attribute. And there are 6 HTML elements, and I'll show you those elements by taking you to the Applications Manager web console. So we are in the Applications Manager web console now. So let me choose monitors, and right here I'm going to choose the website content monitor, and right here you could see the web page, and page size, defacement percent details, defacement script percent, and the text percent information, and the other element defaced. If there is any image which is defaced in your website, you could see the values along with the original content with the modified content. So by analyzing the modified content, you could see what changes has been performed. So Application Manager can show you those details clearly by showing the original content values along with the modified content. So there are 6 basic HTML elements that we monitor in terms of website. That is the text, script, image, anchor, iframe, and link defacement. You could also configure alarms and receive notifications based upon the changes. Let me switch back to the presentation and have a quick recap of what we have discussed. In the today's session, we have discussed about your website's monitoring and the web server, which is actually responsible for delivering your website. We have discussed about multiple web server monitoring like Apache, Nginx in a very detailed perspective that you can monitor using Applications Manager, optimizing the website performance using our synthetic transactions monitoring for the modern web pages. And finally, we have discussed about the website content monitoring using our website defacement analyzer.